Hello learners. In this tutorial, we're going to talk about how to convert a decimal number into a binary number. It will be easy, so let's go ahead and begin. How can we convert 75 into a binary number? It will help if you're familiar with the powers of 2, so we'll do a quick one. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128. Now we don't need to go further because 128 exceeds 75 we have up here. So the highest number, that is the highest base 2 number that is less than 75, is 64. So we're going to start with 64. Now in this series we will go through 2 ways to convert a decimal number into a binary number. The first half of the series will focus on the subtraction method and the second half will focus on successive division. After we're done with the 2 ways, then you can pick which method is better for you. Now once you have your first number, which is 64 in this case, subtract. Let's subtract 75 by 64, and so that will give us 11. Now the highest number, that's under 11, is 8. 16 exceeds 11, so we can't use that. So let's put an 8 here. And then let's subtract 11 by 8. 11 minus 8 is 3. And so the next highest number just under 3 is 2. And so let's put a 2 here. And then 3 minus 2 is 1. And so the next highest number is 1. And we could stop here. Because if you add these numbers, 64 plus 8, that's 72. 72 plus 2 is 74. 74 plus 1 is 75. These 4 numbers add up to 75. Now once you have that, you can begin to write the numbers in binary. So because we have a 64, we're going to put a 1. We don't have a 32, so let's write a 0. We don't have a 16, we put 0. We do have an 8, so let's put a 1. We do not have a 4, so let's put a 0. But we do have a 2 and a 1, that goes 1 1. With this we can say 75 is equal to 100, 1011. And so that's one simple way in which you can convert a decimal number into a binary number. Now here's another example. Let's say if we have the number 142. Let's convert that into a binary number. First let's write the list of numbers we're going to work with. 128, 64, 32, 16, 8, 4, 2, and 1. Now the highest base 2 number under 142 is 128. So let's start with that. If we subtract 142 by 128, that will give us 14. And so the next highest number just under 14 is 8, so 14 minus 8 will give us 6. Let's put the 8 here first. Now the next highest number just under 6 is 4. If we subtract 6 by 4, that will give us 2, so let's put the 4 here. And then 2 minus 2 will give us 0. So we can stop at the 2. Now you can check it, if you type in 128, plus 8, plus 4, plus 2, that will give us 142. Always make sure that these numbers add up to this number. Once you get this far, then you can convert to a binary number. So this is going to be 1, we don't have a 64, a 32, or a 16, so they take 0 each. We do have an 8, a 4, and a 2, but we don't have a 1. So 142 is basically 1, 0, 0, 0, 1, 1, 1, 0. And so that's how you can convert a decimal number into a binary number. Now here's another example. Let's try a bigger number, 339. This time, we'll need a number that's higher than 128. If we do 128 times 2, it'll give 256. FO way higher numbers, just employ this pattern. So we have 256, and then 128, and then 64, 32, 16, 8, 4, 2, and 1. So 256 is the highest number in this list, that's just under 339. And so let's subtract 339 by 256. And so this will give us 83. The next highest number, the highest base 2 number that's under 83 is 64. So let's subtract 83 by 64. And that will give us 19. And let's not forget to write the 64 here. Now the next highest number under 19 is 16. So let's do 19 minus 16. And so that will give us 3. And so let's write the 16. And then the next highest number that's under 3 is 2. And so 3 minus 2 is 1. So let's put the 2 here. And then 1 minus 1 is 0. So we need to include the 1 as well, and then check the work. Make sure that these numbers, all of these base 2 numbers, add up to 339. Type in 256 plus 64 plus 16 plus 2 plus 1. And that will give you 339. Now let's move to the next stage by writing the binary equivalents. Here we have a 256. We do not have a 128. We do have a 64. We do not have a 32. We have a 16. And since we don't have an 8 or a 4, we're going to write a 0. We do have a 2 and a 1, so we'll replace that with a 1. So a 1 means on or yes, and a 0 means off or no. And so this is the answer. So 339 is equal to 1, 0, 1, 0. 1, 0, 0, 1, 1. This is it for this method. Go ahead and practice it again. We'll look at the second method in the next series. Thank you.